Warm good morning to my dear students. So today we are going to see one another important topic in thermodynamics, a reversed Carnot cycle. So what is a reversed Carnot cycle? A reversed Carnot cycle is an idealized thermodynamic cycle using which important equipments like refrigerator and air conditioning works. So we have already seen in second law of thermodynamics, heat flows from a body at higher temperature to a body at lower temperature. But the reverse of the process, that is heat flowing from a body at lower temperature to higher temperature, does not happen. For that to happen, we have to supply additionally work as input. So the refrigerator works on this concept. It maintains the temperature of the space or substance below the temperature of the surroundings. So it works by removing the heat from inside the space or substance and transfers it to the surrounding environment. For that, it needs some work as input. So this refrigerator is a very important household device which is used for storing and preserving food and beverages. So the main components of a refrigerator includes a compressor, a condenser, an evaporator, and an expansion valve. And there is a working fluid inside the refrigerator, and that is called as a refrigerant. So what is the function of each individual component? First, we will take the compressor. A compressor is a device which is used for compressing the vapor refrigerant to high pressure and high temperature. So this vapor refrigerant, which is compressed, travels to the next device, that is condenser. So a condenser is a device which is used for condensing the vapor refrigerant into liquid refrigerant. So for condensing a vapor into liquid, the latent heat has to be removed from the vapor. So when the latent heat is removed, the vapor converts into liquid. So during this conversion of this vapor into liquid, the pressure drops. Now the liquid refrigerant at low pressure, it enters into the expansion valve. Inside the expansion valve, the expansion of the liquid refrigerant happens. So this expansion of the liquid refrigerant results in sudden drop in temperature of the liquid refrigerant. So this low temperature, low pressure liquid refrigerant coming out from the expansion valve enters the evaporator. So evaporator is nothing but it is a device which contains number of coils wound in the form of a sphere or throughout the refrigerator or throughout the space which has to be maintained at low temperature, the evaporator coil completely covers. So the liquid refrigerant at low temperature and pressure enters these coils of the evaporator. So when it circulates through the coils of the evaporator, it absorbs the heat inside the space or substance and thereby maintains the temperature of the space or substance below the temperature of the surroundings. Now this refrigerant, after absorbing the heat, it absorbs the heat in the form of latent heat. So when it absorbs this latent heat, again it gets converted into vapor and it again goes to the compressor. So this completes one cycle. So what are the four processes what we have seen here? That is a compression process, then a condensation process, then we have an expansion process, and then we have an heat absorbing process. So all these four processes completes one cycle, and that is a reversed Carnot cycle. So reverse Carnot cycle is an ideal cycle where we can expect the coefficient of performance to be very high. But in actual case, there will be some losses that happens. So it will be lesser than the actual case, and the reverse Carnot cycle is used for comparison of the actual performance of the refrigerator. So reversed Carnot cycle is a theoretical thermodynamic cycle that describes the most efficient way to drive a reversed heat engine, that is a refrigerator. It is often used as a benchmark for comparing the efficiency of real world refrigerator.